Okay, now I'm going to tell you about the 45, 45, 90 special right triangle. And remember, it's called that, the 45, 45, 90 triangle, because of the size of the angles. So this is the other special right triangle you should know all about. And we worked on it in this worksheet to find the pattern. So if you completed this, you probably noticed that in every one, the two side lengths were the same, A and B. So the two legs of the right triangle were the same. So if we're talking in terms of variable, if this is x, this is also going to be x. And that's because if you turn this the other way and look at the triangle the other way around, it is an isosceles triangle. And we know on isosceles, these two legs are always the same. Then the other pattern you probably noticed using the Pythagorean theorem is that C, the longest side, or the hypotenuse, was always the side length times radical 2. So 3 times radical 2, 4 times radical 2, 5 times radical 2, 6, and then 7 and 8. And so on. That pattern continued down here as well. The radical 2 doesn't always appear. It just means that we know that to get from the side length to the hypotenuse, I have to multiply by radical 2. So this would be x times radical 2. And I know to go from either side length, I'll just draw it on one side, but I could also go from this side to the hypotenuse, I would multiply by radical 2. But if I wanted to go in the other direction, I would do the opposite operation again and divide by radical 3. I'm sorry, radical 2. So right here I can use this to help me solve for the missing sides. I know that because x is the other leg on the right triangle, that x is going to be the same as this leg, so it's just going to be equal to 11. Then I know that to go from a leg to the hypotenuse, I need to multiply by radical 2. So to find w, I'm going to do 11 times radical 2, which cannot be simplified further than that, so it's just 11 radical 2. Okay, and then just like on the other special right triangles, you need to be careful about which way the triangle is oriented. So this one is kind of upside down, so you have to think about this as you have to look at the angles, where the angles are, to help you decide which side is which. So I know that this side is across from the 90-degree angle, so it's going to be the longest. And I know that to go from the longest, or the hypotenuse, I need to divide by radical 2 to get to side length. So I'm going to take 18, and I'm going to divide it by radical 2. And then again, we cannot have a radical in the bottom, or the denominator of a fraction, so I'm going to multiply by radical 2 over radical 2 to cancel that out. So I end up at 18 times radical 2 on top. And this turns into radical 4, which can be simplified because 4 is a perfect square. And the square root is 2. But then I can simplify these numbers, the coefficient and the denominator, and I end up with this being equal to 9 radical 2, because those two numbers can be simplified again. So that is both sides. So again, what I did was I, from the hypotenuse, divided by radical 2. And I knew that that was both side lengths because, again, this is an isosceles triangle. And so z and y are both going to be the same. So I'm done.